Change is a very important part of God's created universe. Think about all of the changes that happen here on Earth. We experience seasons every year: spring, summer, fall, winter. Every year we experience differences in weather patterns: tornado season, hurricane season. Living things here on Earth go through all sorts of changes during their lifetime: growth, they learn things, reproduction, even death. Change is a very, very important part of the world. And in this lesson, we're going to be trying to wrap our heads around some changes that happen with matter. Now, some of these changes are actually called physical changes because they just change the properties of matter. And some of them, the ones we're really going to be focusing on in this unit, are chemical changes that change the very nature of the matter itself by changing it into different matter. That's what we're going to be learning about as we consider chemical changes in today's lesson, also known as chemical reactions. But in order to understand chemical changes and chemical reactions, you really have to first understand what physical changes are. And again, physical changes are changes that do not change substances to different new substances that weren't there before. As we consider physical changes, let's think of a very common substance. We'll think of sugar. Here I have rock candy, which is pure sugar, pictured on the right, and a sugar crystal pictured on the left. Sugar, as you can see, is made up of three different kinds of atoms: carbon, oxygen, and hydrogen. As you think about those three types of atoms, you might realize that all three of them are nonmetals. That makes sugar a covalently bonded substance. And as you may be able to tell from the picture, because it's bonded into crystals, sugar is a polar covalent substance. So it has the strongest forms of the weak bonds, hydrogen bonds, holding the molecules of sugar together. Now, what would happen if we pounded sugar with a hammer? What would happen to this crystal if we pounded it? This is what would happen. The sugar that once made a crystal would instead make smaller crystals, granules of sugar. Here I have a picture of rock candy next to granulated sugar, sugar that's been pounded so the crystals are now smaller than they were before. Notice, I didn't actually break any of the chemical bonds holding the sugar together. Chemical bonds are ionic or covalent bonds. These sugar molecules are still covalently bonded together in the exact same arrangement as they were before. The only bonds that I broke were the weak bonds, the bonds that were just responsible for holding the sugar molecules together in their solid crystal form as one big crystal. So because I didn't actually change the chemical bonds holding the substance together, that was a physical change when I pounded the sugar. It's still sugar molecules. It's still the same substance. What about a different change? What if I took water molecules and I mixed the sugar molecules in with them so the sugar dissolved in water? Is dissolving something a chemical change? Well, please notice, once again, I've taken away those weak hydrogen bonds entirely because now the water molecules are being attracted to the sugar molecules. But I didn't actually break apart the sugar molecules into a different substance. I still have sugar molecules now mixed in the middle of water molecules. This was a physical change because dissolving sugar in water doesn't break any of the chemical bonds. Let's get rid of the water molecules and let's consider another change to a sugar crystal. What if I heated the sugar crystal up and melted it in a hot pan? Would that be a chemical change? Well, watch what happens to the sugar molecules. The sugar molecules are going to break apart from those weak bonds that were holding them together, and they're going to separate away from one another and start sliding past each other instead of just vibrating in a fixed place. This is also a physical change. Melting and evaporating a substance is a physical change because it doesn't actually break the bonds holding the covalent substance together. It doesn't change it to a different substance. All right, so these are all physical changes. So then what in the world is a chemical change? A chemical change occurs when Substances actually break the chemical bonds holding them together and then bond together with something else a different way. They form new chemical bonds. Let's take a look at a substance undergoing a chemical change. And again, we're going to take a look at sugar. Okay, and sugar can combine with oxygen and undergo a chemical change and completely become something different. Please notice on this slide what's present. I have one sugar molecule and 6 oxygen molecules, and that's it. This sugar molecule is going to react with the oxygen when I add heat to it to burn and make 2 new substances, water molecules and carbon dioxide. Now notice that sugar molecule that was bonded together with covalent bonds isn't even here anymore because the atoms that made it up are now changed to different substances. They're bonded a completely different way. Now, let's just go back and think about that in depth a little bit more. And we're actually going to learn a couple more terms as we think about that. The reactants of that reaction that you just saw were the substances that were present before the reaction occurred. Now, you may remember what those 2 reactants were. We had a sugar molecule, that's this molecule, and then we had 6 oxygen molecules as well. These were the substances present before the reaction. By the way, something else important. If you count up the different kinds of atoms, you should notice there's 6 carbon atoms, those are the black ones, 12 hydrogen atoms total, those are the gray ones, and when you count all of the oxygens in both of the reactant substances, you should notice there's 18 total oxygen atoms before the chemical reaction happened. Then the reaction happened, and we produced new substances at the end. The substances we produced at the end were carbon dioxide molecules and water molecules. Hey, count up the different types of atoms one more time. You notice before the reaction we had 6 carbons. How many black carbon atoms do we have after the reaction? You notice there's 6 of them? We had 12 hydrogens before the reaction. How many hydrogens did we have after the reaction? When you count them up, you notice there's still 12. And what about the oxygens? We had 18 before the reaction. After the reaction, we have 18 still. So we didn't change the number of atoms when this chemical change happened. The chemical change just changed the way the atoms were bonded. By the way, what you're looking at here is something significant. This is known as a reaction equation. And what it does is it gives us a mathematical way to predict how one group of substances and exactly how many of each of those parts of those substances. So we have 1 sugar molecule and 6 oxygen molecules. We know the number of them. How those are going to change into something different after a chemical reaction. We know the number of carbon dioxides and the number of waters that those sugar and oxygens are going to turn into. So, a chemical change occurs when a substance becomes a new substance by breaking its covalent or ionic bonds, the chemical bonds, and forming new covalent or ionic bonds after the reaction.